Welcome to Brain Vision.
Okay, so problem 28.8, you have an electron and proton that are each moving at a certain speed in perpendicular paths as shown. And at the instant that they are at these positions, we're supposed to find the magnitude and direction of the total magnetic field they produce at the origin to start. Okay, so first off, we're going to start off with the electron. We have the magnetic field, and that's going to be due to a moving point charge, so that's going to be mu naught over 4 pi. And then we have Q, the charge of the electron, and I write down as negative. And then we have the distance squared, so that's 5 nanometers squared. And then we have the velocity, and that's the cross product of the velocity with the r vector. So that's going to be this r vector here. It's from the point to the point. It's from the point where the charge is to the point at the origin. That straight line down. So then we have the velocity. We just have the number, the magnitude, and we have the direction for the velocity is negative I hat. That's to the left. So negative I hat. Cross product with the vertically down vector. So that's negative j hat. Okay. And so what we're left with is numbers up to the point where we have the cross product. And so that's going to come out to a negative 0.5 millitesla. In the negative I hat cross negative j hat comes out to be k hat. So then we can rewrite this as 0.5 millitesla in negative k hat direction. So at the origin, this produces the magnetic field vector into the page. Okay, now for the proton, we do the same thing. What's different is we have a different distance, and we have different cross products. So I'll write down this QE this time for positive. That's the electron. That's the charge of the proton over 4 nanometers squared. The velocity is the same, 735. And then we have that as the velocity vector. The direction is down, so negative j hat. And then the r vector this time is in towards the origin. So it's going to be cross product with negative I hat. And this is going to be negative j hat across negative I hat is going to be negative k hat. So again, we're going to have a positive number out front like we have here, but then negative k hat. So that's going to be 0.7. I'm glitching here. 0.736. Again, I'm getting some glitching here. So 0.7436 millitesla and a negative k hat direction. Okay, and then we can add these together. So then in all, this would be 1.236 millitesla in the negative k hat direction. Okay, so B, the magnetic field that the electron produces at the location of the proton. Okay, so it's a little different. We have to find the magnetic field that the electron causes at an angle. It's not straight perpendicular to its velocity. So this time it's an angle back to the proton. So that's going to change our cross product a little bit. So what we need to do is we need to just start out by writing down what the magnetic field of a moving charge is. So that's going to be magnetic field is going to be mu naught over 4 pi, same as before. Electron charge. And we have over the distance squared. So what's this distance squared? So that's going to be, let's see, Pythagorean theorem. So we have 5 squared plus 4 squared equals 41. squared, 41. So then what we can write is we can write 41, and let's distinguish 41 nanometer squared between the other 41 nanometer squared. In this case, we only are squaring the units themselves. So then we can write this. Okay, and I really should write this as negative. And we have velocity. And then so the cross product of vectors that are at an angle, we can use the sign for. So sine, and it's going to be this angle here, because this is the r vector going down towards the proton, and we have left being the velocity vector. So it's going to be 90 degrees, because this is a right angle plus whatever this is. And so we can use trigonometry. We have the inverse tangent of 4 over 5. Units cancel out. And so that gets to be 38.66 degrees. So then we can take that 90 plus 38.6. So then we get 90 plus 38.66. And so all we have is numbers and units, so we can solve this. So then we get sine of that number. So then we get 0.2243. It's going to be millitesla. So it should be less than what we got before for when it was straight down. So that makes sense. And it's going to be negative k hat direction once we account for this negative here. Okay, so now we can find the total electric force and total magnetic force that the electron exerts on the proton. And let's do this on the second page. So the electron force, the electric force of the electron acting on the proton, we can write as 1 over 4 pi epsilon naught. And then we have the charge of the electron is negative QE. The charge of proton is QE. And then that's over the quantity. Actually, we can start off with x, the x direction, and then we can write the y direction as well. So we can have 5 nanometers squared. So this is going to be force in the x direction, and then that's going to be negative I hat. So as we see in the previous one, that they're going to be attractive to each other because they're opposite charges. So in the horizontal direction, the x direction, the proton is going to be attracted. It's going to be pushed. It's going to be forced to the left. But then in the y direction, we have the same thing: 1 over 4 pi epsilon naught. We have again the same charges for 4 nanometers in the vertical direction. And the force is going to be in the positive j hat direction. Okay, so then what does this come out to be? This comes out to be negative 9.23 times 10 to the negative 12 newtons in the negative I hat direction, comma with negative 1.44 times 10 to negative 11 newtons in the j hat direction. So that's an I. Okay, so we can cancel out those if we want. Actually, I messed something up here. So negative I hat. Actually, that should just be positive right there. So that should be positive. Okay, so we're not distinguishing what the direction is in this vector here. Okay, then the electric force, then the force due to the B field. So this is the second part of that problem, finding the force due to the B field of the electron acting on the proton. That's going to be Q V cross B. So that's going to be the velocity of the proton crossed with the B field of the electron. So we already found the B field of the electron in the previous part. So that's part B. So we can take that. Actually, we can take a part of it. And so what we get then is mu naught over 4 pi. And basically taking this solution here with this solution, we can find out what it is. So we have, let's see, QE squared over 41 nanometers squared, V squared, because we have two V's in the previous part. And then, so we found that out to be negative K hat magnetic field. So then we can take negative J hat, that's the direction of the velocity vector for P, for the proton, crossed with negative K hat. And so that comes out to negative I hat. Actually, it just comes out to I hat. So then one of these was negative. So we get 3.38 times 10 to the negative 17 newtons in the negative I hat direction. So this cross product comes out to be positive I hat, but we have a negative here, so it's negative I hat. And does this meet our expectations? So we have E field is a negative K hat direction, V is downwards. So we have the cross product of negative J hat cross negative K hat. So that should be negative I hat. No, something messed up here. I don't think we do that. Okay.